Assalamualaikum warahmatullahi wabarakatuh. Hi everyone, my name is Madam Maisarah. Today we continue with lecture 3, chapter 5, function and graph. For this lecture, cover chapter 5.3, inverse function. Objective. At the end of the lesson, students should be able to show whether a function has an inverse and find the inverse of the function, compute the inverse of a function, identify the domain and range of an inverse function, and lastly, sketch the graph of the function f and f inverse on the same axis. Let's get started. Before we continue with our lecture, let's try to do one activity. First step, you need to draw graph of y equals to 2x minus 3. This is a straight line with gradient m equals to 2 and y-intercept negative 3. And then on the same axis, you draw y is equal to 1 over 2 multiply x minus 3. This is also a straight line with m equals to 1 over 2 and y-intercept negative 3 over 2. And then you draw line y equals to x. This is also straight line with m equals to 1 and y-intercept is 0. Then after you draw, you fold along the line y equals to x. This is the graph of y equals to 2x plus 3, y equals to 1 over 2 multiply x minus 3, and y equals to x. After you fold along the line y equals to x, you will notice the blue line and the green line will overlap on each other. So, the two graphs overlap on each other. So, we can say y equals to 1 over 2 multiply x minus 3 is an inverse for y equals to 2x minus 3. And it's verse. The inverse of a function. The mapping of the domain with element negative 3, 0, 1, 2 by the function fx equals to 3x minus 2 can be represented in arrow diagram. This is a function f is mapped from x to y. And the function f inverse is mapped from y to x. We can see f negative 3 is equal to negative 11 and f inverse negative 11 is equals to negative 3. Existence of inverse function. The inverse of a function f exists if and only if f is one-to-one function. So, if f is not one-to-one function, so the inverse function does not exist. You need to remember this. So, the existence of inverse function is relate to one-to-one function. Two methods to determine one-to-one function. The first one is by using graphical method, which is horizontal line test. The second one is algebraic method. Methods to find the inverse. There are two methods to find the inverse function. The first one is algebraic method. Let y equals to fx, then x equals to f inverse y. Or the second method is by using the property f inverse, f composite f inverse is equal to x, or f inverse composite fx equals to x. Let's look at example 1. The question asks to show that the following functions are one-to-one. Find the inverse function. Question A. fx equals to 3x plus 2. Question B. px equals to negative x squared plus 5 for x more or equal 0. Okay, first we want to show the function not one-to-one or not. So for function, question A, function f(x) equals to 3x plus 2, there are two methods to show one-to-one function. First, we try to do a graphical method. Okay, to use graphical method, we need a graph. So we need to sketch the graph. So this is the graph of f(x) equals to 3x plus 2. This is straight line with m equals to 3 and c equals to 2. Then by apply graphical method, which is horizontal line test, we need to draw horizontal line. So we draw horizontal line. This is the green dotted line. This is horizontal line, and we observe the line, horizontal line cuts the graph only at one point. So any line parallel to x-axis cuts the graph y equals to 3x plus 2 at only one point. Thus, f is one-to-one function. So f(x) equals to 3x plus 2 is one-to-one function. So then f inverse exists. So then we try to do second method, algebraic approach to show one-to-one function. For question A, f(x) equals to 3x plus 2. So by using algebraic approach, let fx1 equals to fx2. So then we substitute x1 into fx, we substitute x2 into fx, we get 3x1 plus 2 equals to 3x2 plus 2. And then we bring 2 to on the left hand side to the right hand side, and we get 3x1 equals to 3x2. So finally, we divide by 3, we get x1 equals to x2. Since fx1 equals to fx2 implies x1 equals to x2, thus f(x) is one-to-one function. This is by using algebraic method to show one-to-one function. You can choose either graphical method or algebraic approach. I show you both method. Okay. Since function f(x) equals to 3x plus 2 is one-to-one function, so then f inverse exists. To find the inverse function, we can use property f composite f inverse is equal to x. So f inverse we put into x on f(x), so then we get 3 f inverse of x plus 2 equals to x. So then we want to find f inverse x, so we bring 2 on the left hand side to the right hand side, we get 3 f inverse equals to x minus 2. So then we divide by 3 both on the both side, we get f inverse of x equals to x minus 2 over 3. So the inverse function of f is x minus 2 over 3. So let's continue with solution. Question B. The function is px equals to negative x squared plus 5 for x more or equal to 0. So x more or equal to 0 is a domain for px. So 0 close 0 to infinity is a domain of px. So then you need to draw, if you use graphical method, you need to draw and follow the domain 0 infinity. So means that your x is your graph is on the right side of x, right positive x. So the graph should be like this. So then to use graphical method, which is horizontal line test, we need to draw a horizontal line and then we observe the line, horizontal line cuts the curve only at one point. So then any parallel line to x-axis cut the graph at only one point, thus px is one-to-one function. So since px is one-to-one function, inverse of px exists. So this is to show one-to-one function by using graphical method. For second method, which is algebraic method, we want to show Px equals to negative x square plus 5 for x more or equal to 0 is one-to-one function. So let Px1 equals to Px2, and then we substitute x1 into Px, substitute x2 into Px, we get negative x1 square plus 5 equal negative x2 square plus 5. And then we bring 5 on the left hand side to the right hand side, we get negative x1 square equals to negative x2 square. So then we get x1 equals to plus minus x2. But since is given x more or equal to 0, thus x1 is equal to x2. So we ignore x1 equals to negative x2 because the domain given is x more or equal to 0. So therefore Px is one-to-one function. To find the inverse function, we can use by using property f composite f inverse of x equals to x. So then negative f inverse square plus 5 equals to x, we substitute f inverse into fx, and then we get f inverse x square equals to 5 minus x. We bring 5 on the left hand side to the right hand side, and then we square root both sides, we get f inverse equals to 5 minus x for x more or equal to 0. Domain and range of inverse function. A function f is mapped from x to y, and a function f inverse is mapped from y to x. From the diagram, domain of f is equal to range of f inverse. Range of f is equal to domain of f inverse. With the property of the inverse function, domain f is equal to range of f inverse, and range f is equal to domain f inverse. That means point xy of fx is changed to yx of f inverse and achieved by reflecting the points about y equals to x. The graph of y equals to f inverse is obtained by reflecting the graph of y equals to fx about the line y is equal to x. Let's look at example 2. Find the inverse of fx equals to 1 over 1 minus x plus 2 for x does not equal to 1. And state the domain of the inverse function. This is state domain f inverse. To find f inverse, we use property f inverse equals to x. So then we substitute f inverse into fx, we get 1 over 1 minus f inverse x plus 2 equals to x. So then we multiply all with 1 minus f inverse. So then we get 1 plus 2 minus 2 f inverse equals to x minus x f inverse. And then we factor f inverse, we get f inverse x minus 2 equals to x minus 3. Finally, f inverse is equal to x minus 3 over x minus 2. And then we want to find domain of f inverse. Since f inverse is a reciprocal function, so x does not equal to 2. Since x minus 2 does not equal to 0, so then we get x does not equal to 2. So then the domain of f inverse is equal to negative infinity to union to infinity. Let's look at example 3. Function f and g are defined as fx equals to 2x minus 5 over x plus 3, gx equals to 3x plus 5 over 2 minus x. Both f and gx are rational, are reciprocal functions. Find f gx and deduce f inverse. Determine the domain and range of F inverse. Let's look at for solution of example 3. First, we want to find f gx. So we find composite of f gx. So then we substitute gx into f. Then we get f 3x plus 5 over 2 minus x. So means that we substitute 3x plus 5 over 2 minus x into x on fx. We get 2 multiply 3x plus 5 minus 5 multiply 2 minus x over 3x plus 5 plus 3 multiply 2 minus x. And then we simplify, we get 6x plus 10 minus 10 plus 5x over 3x plus 5 plus 6 minus 3x. And we simplify, we get 11x over 11, which is equals to x. So then our FGX equals to x. Since FGX equals to x, it's similar to property F inverse equals to x. So we can deduce F inverse is equal to Gx, which is equal to 3x plus 5 over 2 minus x. So now we want to find domain of F inverse and range of F inverse. Since F inverse is equal to 3x plus 5 over 2 minus x, so then the domain F inverse 2 minus x does not equal to 0, so then x does not equal to 2. So then the domain of F inverse equal to negative infinity 2 union to infinity. And then we want to find range of F inverse. Range of F inverse is equal to domain F. So the domain F is negative infinity, negative 3 union negative 3, infinity. Let's look at example 4. The question asks to find, given that fx equals to x minus 1 square plus 2 for x more or equal to 1. For x more or equal to 1 is a domain of f. So the domain of f is close 1 infinity. Find f inverse and state its domain and range. Hence, sketch the graph of fx and f inverse on the same axis. Since fx is a quadratic, but the domain given is 1 infinity. So you need to sketch the graph of fx, follow the domain given. Let's look at for solution example 4. First, we want to find f inverse. So to find f inverse, we use property f inverse equals to x. So we substitute f inverse into x on fx. We get f inverse minus 1 square plus 2 equals to x. So then we bring 2 to the right hand side. We get f inverse minus 1 square equals to x minus 2. And then we square root both sides. We get f inverse minus 1 equal to square root x minus 2. So finally we get f inverse equals to surd x minus 2 plus 1. So f inverse is a surd function. So since the domain of f is x more or equal to 1, so then domain f equals to range f inverse. So jadi range f inverse is close 1 infinity. And the domain of f inverse is followed by x minus 2 more or equal to 0. So then we get x more or equal to 2. So then the domain of f inverse is close to infinity. Hence, sketch the graph of fx and f inverse on the same axis. The last question for example 4. So we want to draw, first we draw fx. fx is x minus 1 square plus 2. We must draw for domain x more or equal to 1. So first we draw x-axis and y-axis. And then we draw reflecting line y equals to x. And then we draw fx. fx suppose the domain is 1 infinity. So this is quadratic. We draw fx. This is fx. The red curve is fx. And then we want to draw f inverse by reflecting the graph y equals to fx above the line y equals to x. So we obtain y equals to we obtain f inverse by reflecting fx. So then we get f inverse, the graph of f inverse is the blue curve.